Hello everyone, good afternoon. My name is Sagar Sonwane, and I hope everyone is doing well and enjoying the conference so far. So today I'll be speaking about a feature that got released in Go version 1.18. Does anyone remember what was the highlight of version 1.18? Generics, right? But there were other features that got introduced in that particular version, which didn't get that much limelight because of generics. And one of them was fuzz testing. So today, I'll be talking about fuzz testing. Okay. Pointer, yes. So before moving on to that, let me first introduce myself. My name is Sagar Sonwane, and I am working as a senior software engineer at Josh Software. It's been 3 years since I started my career as a software engineer, and I've been working in Go ever since. So I think we should get started. Everyone, I would like you all to meet my friend Ross. Ross is a fellow gopher, and he just switched his career from being a paleontologist to a software engineer. So he's new to the field. Don't judge him. So first task that Ross gets in his career is to write a reverse function, a simple reverse function, right? And I think he also thinks the same, that it is very simple to do, and he don't have to worry about anything. Just look at his face, so smug, not even looking at his screen while coding. So this is the reverse function that he wrote, which accepts a string as an input, converts it into byte slice, since string is nothing but byte slice only, and does the byte swapping, and returns the reverse string. And just to make sure that his code works properly, he has also written the test cases. I think this covers most of the cases, like hello world, an empty string, and some numerals with special characters. Looks good, right? But our guy, Ross, is under the assumption that since he has written the test cases, nothing can go wrong with his code. Don't we all assume the same? But something happened. He missed an edge case. And Ross's application crashed because of that edge case. I think this has happened to each and every one of us at least once, that we thought we wrote some amazing code, we tested everything was working fine, but as soon as it hits production, bam, it crashes. So same thing happened to our buddy Ross as well. Now, Ross is confused that what just happened. He had written test cases, he did the manual testing, everything was working fine on the system, but what went wrong? So while looking at logs, he was able to find something, that someone had given an input string, yen 1000, to his reverse function, which in turn came out to be this 0001 question mark. So this shouldn't be the answer, right? This shouldn't be the output for his reverse function. Can anyone guess what went wrong here? Sorry? Yes, this character, the yen symbol, it is a Japanese currency symbol, which is a Unicode character. And Unicode characters take more than 1 byte to store value, like some of it. So the input string was kind of like that in byte slice. And 194, 165 represents the yen character. And when his function reversed that, it became 165, 194, which messes up the resultant string. So this is what went wrong with his code. Now, Ross is thinking that neither he wants his code to break, nor he wants to write million test cases for every program he writes. Because honestly speaking, most of you will agree with me when I say we hate writing test cases, right? And not because it is impossible, but it is daunting to just think of all the cases which could fail for your code. So now, in search of something which could help him with solving this kind of edgy test cases, Ross stumbled upon something called fuzzing. So what is this fuzzing thing? Even the name is a little bit fuzzy, right? So fuzzing is nothing but a type of automated testing which continuously manipulates input to a program to discover coding errors and security loopholes. So instead of testing your program with small predefined set of inputs, what it tries to do is it comes up with new entries, new inputs, and it tries to test your program against that. And in turn, it is able to find logical and functional bugs in your code. So with version 1.18 release of Golang, it started supporting fuzz testing natively along with the already supported unit testing and benchmarks. By the way, this doesn't mean Golang is, fuzz testing is new to Go, but it was already there, but through third-party libraries. And one of them was GoFuzz, if someone knows it. So it was developed by Dmitry Vyako, and it was actually very popular, you know. So you see, these are like so many bugs which were detected by this GoFuzzing library, and that too in Golang standard repository, code repository. And it has around like more than 500 issues that are listed. Some of them are in protobuf library, some of them are in Hugo, CockroachDB, Golang standard library, and many more. So it was able to detect like this many errors, and maybe some are already not listed here, but they were discovered through GoFuzz. So I think that probably made the case for the introduction of fuzz testing in Go standard library. By the way, fun fact, before every release of Go, Go team also tests all their features against fuzz testing. So now let's see how can we write fuzz test for our Golang program. So there are certain rules that you need to follow in order to write a fuzz test for your Golang program. And it is kind of similar to how we already write test cases and benchmarks. So you just have to start your test name with fuzz keyword instead of test or bench. And you need to pass testing.f argument to your function. So this is a basic skeleton on how a fuzz program should look like. And all the fuzz tests should also exist in underscore test file, like our unit test. Now, there are two major APIs that are exposed by fuzz testing library. One of them is add, and one of them is fuzz. So we will look at it in later slides. But let me first tell you about corpus, since this term is going to come up again and again while we are discussing fuzz testing. So corpus is nothing but a collection of input that guide the fuzzing. That means while the fuzz testing process is going on, fuzz engine comes up with new entries. So those are stored in form of this corpus. And there are two types of corpus. One is the seed corpus, and one is generated corpus. So seed corpus are the entries that we provide to the fuzzer to give it a head start. So let's say your program is expecting some special kind of input, and when fuzz test tries to run, it tries to come up with all the possible entries for your program. So if we give it a seed corpus, like pre-defined entries, like maybe from the ones we are using for unit test, it can get a head start, and it can start making new entries with the help of seed corpus entries, which are already there. And the generated corpus entries are those which are generated at the runtime while fuzz test is running. So this is how the first part of our fuzz test looks like, where we are adding the entries to seed corpus. So generally, whatever you have written for unit test, whatever input you are giving, you can add this to the seed corpus. And seed corpus is optional. Fuzz test can come up with entries which are relevant for your program, but it will take some time if you don't give the seed corpus. And the second part is the fuzz target. So this is where the main parts come. Here, what we are doing is we are testing our original function. And you see this fuzz function is taking one argument, that is fuzz argument. So these arguments are generated at random while the fuzz test is running. So since our reverse function expects only one string argument, that's why we are giving only one argument as fuzz argument. And this is getting generated randomly at runtime while fuzz test is running. So don't worry about the code. We will take a look at that in live demo. So I'll show you a live demo of how fuzz testing works. And please bear with me if juniors try to screw this up. Yeah, so the screen is visible to you all, right? Font is visible till the back? Okay, I'll try to increase it a bit. Is it now? Better? Yeah, okay. So this is what we had before, a simple reverse function, which was written by Ross. Now, what we will try to do is, we will just try to run this program, and we'll see how it is working. So you see, it is giving us the original string, and we reversed it, and we also printed the reverse string. Working fine, right? Now, we will also try to run the unit test cases that Ross had already written. So this we saw in the previous slide, that these are the test cases written by Ross. And we will just try to run them as well. All the test cases are passing, right? So just for the sake of demo, what I'll do is I'll comment this, and we will directly go to our first test. So just to save some time, I had already written this, since we already saw this in slide. Okay. So let me walk you through with the first test once again. So here we are adding the entries to the seed corpus. All right. So whatever entries we had, that is hello world, empty string, and this numerals, we are passing it to seed corpus. Then we are defining a first target. So this first target has one argument, which is this original string, and it is going to be mutated at runtime, and new entries will be generated and tested against our function. Now, there is a limitation with first test, that you do not know what the input is going to be your function. So in that case, you have to rely on something called invariants. So invariants are those conditions for your program which will always hold true, right? So in the case of our reverse function, what is going to be true every time? That the double reverse of original string should match the original string only, right? So this is what we have done here, that we are checking if the original string is matching the double reverse or not. If it is not, then there is a problem. And the second thing is, the reverse string should preserve its valid UTF-8 state. So this is also we are checking that original is valid and reverse is valid or not. If it is invalid, then we are also throwing an error. So this is how a first target looks like. Here we are calling our reverse function, then we are checking the invariants. Now there are two ways you can run your first test. So if you just try to run go test command, what it will do is, it will just run your first test as unit test. So you see we had 3 entries in seed corpus. So it tested your 3 entries against this first target as a unit test. And now we are going to do the real first testing. So you just need a first flag to invoke first testing, and you need to just give a regex for the function name you are trying to first test. So as I run the program, it was able to detect an issue within 1 second of running. You see there is some information given here, that elapsed time and what not. But let's focus on this fail first. That it is showing that this function failed on line number 31, showing reverse is invalid. And it has also saved that input for which our function failed. So, and it is saved in the same file. By the way, seed corpus entries just not involves the entries we give them, but also the entries for which our function fails, so that you can use them as for regression later on. So you see, for this particular entry, our function failed. And this is again a Unicode character, maybe a Chinese symbol, I guess. So what we need to do to fix this reverse function now? So generally, we have a data type in Golang which can help us with Unicode characters, that is rune. So just to fix my program, what I need to do is, instead of using a string of bytes, slice of bytes, I will use a slice of runes. And after that, what I'll do is, I'll just try to again run the unit test to check if it is passing for all the present seed corpus entries, including the failed one. Now you see there are 4 entries in seed corpus, the 3 which we provided, and the 4th one which our function failed for. So now the unit test cases are passing. And again, as I run the first test, was again able to find one more bug in our code. Did anyone realize there are more than one bug in this code? So yeah, there are. So just to save some time, I'll tell you what the bug here is. So let's just check out. So this string input, which is given to our program, this is actually not a valid UTF-8 string. And since we are not checking that, that's why the program failed at this particular line for the second condition, that this original is not a valid UTF-8 string. So we will fix this quickly. I'll just add a check. If not, UTF-8 dot valid. Now the program is fixed, I guess. Let's try to run the unit test again. And now all the entries are passing. So you see all the 3 cases which we had already given and the 2 which ones are detected. All the cases are passing. And now we will try to run the first test again. You see it has continuously run for now 6 seconds, 10 seconds, but it was not able to find any more bugs in our code. So if you want to stop first test, it is a continuously running process. It continuously goes on in your code and tries to find out more and more bugs. So there are only 3 conditions when this first test stops. If it panics for some reason, like your code fails.
Sure.
Other one is if you manually kill this process, that is to maybe Control C, which I did just now. And if you set a time limit, so there is one more option to set a time limit to run the first, that you can run first test for like 5 seconds, 10 seconds. So yeah, this is how first testing works. And let me just like walk you through with the details here. So it is showing us the elapsed time, the time it is testing your first target. This baseline coverage is nothing but the combination of already generated corpus and seed corpus. So while you are running first test again and again, it first goes through all the entries which are present in corpus and then tries to generate new entries. And then here we see exits. So it is showing us it went through like 6,20,000 entries within 3 seconds. So it is that fast. And it is trying to come up with more and more entries, trying to run your first target parallelly across all like 12 workers. It is showing that it is running first test with 12 workers. So it is that fast. So now coming back to demo. Yeah, this was mind-blowing, right? So simple, yet so powerful. This would have easily taken hours, if not days, for us to find those 2 bugs in our code. Because like it is kind of impossible to find these kinds of edge cases. Now, as we have seen how first testing works practically, let's also understand the internals of it. So there is a fuzz engine in action there, which under the hood uses coverage guided fuzzing. That means it tries to come up with new entries which try to execute more and more of your code. So if, as you see here for the example, it has come up with an entry AAA. So because of that entry, it was able to execute a new branch in your code. So this is kind of a coverage guided fuzzing, we can say, because it is trying to explore more and more of your code and trying to generate new entries which could do it more often. Now, after looking at the demo, I think there are some obvious reasons that why would we need fuzzing. Humans are not very good at finding edge cases. So that's when first testing comes in and tries to look for it and help us with finding all those missing edge cases. and human writes biased test cases. So whenever we are writing unit test cases, we think we just test for whatever there is information in front of us, what can go right, what can go wrong, but they don't think of all the cases. It can identify bugs which unit tests cannot. Like those were the just two bugs which we were able to find. But it can also find like crashes, hangs, timeouts, race conditions in your code. So it is that powerful. And if you don't fuzz, some attacker might do it for you. And that is not going to be good for you when that happens. Now, what to fuzz? That's a good question, right? Even though we have all the code, but that doesn't mean we need to test everything. So in order to identify what to fuzz, we should ask ourselves few questions before going on and fuzzing something. So there are few thumb rules or few questions that I like to ask myself. If my code lies in one of these categories, I'll go ahead and try to first test it. So is your API publicly available? Because if your API is publicly available, it is prone to many attacks. Some attacker might try to exploit it and try to find out like inputs for which your application crashed. Is your source trustworthy? For example, like in IoT devices or embedded softwares, data is coming from many sources. So in that case, you do not have to rely on what data you are getting. You have to be prepared for anything and everything. Is your API expecting high traffic and deals with complex inputs? So in that case, you also need to be aware of what all missing edge cases are there in your program. And if you're trying to like write some important algorithm or business logic, which you want to be bulletproof, in that cases, it is also logical to use first testing before going on and doing with that. And also you can do it just for fun, because it is fun, right? You were able to identify bugs which your code had, but you didn't realize. So the problem, there are some general problems fuzzing can identify. I generally classify them in two parts. One is unexpected behaviors. So let me tell you a problem that I faced while I was working on a security domain project last year. So we had this tech stack in which we had REST API server and one auth server. And REST API server stores the data in MySQL, and auth service stores the data in Postgres. So for some reason, we had this like different databases. So one day on production, someone tries to like play around with our APIs. And at that time, they inserted a null character in an input field for one of our APIs. So what happened was, when that request came to REST API server, it processed the request and stored the data in MySQL database. Then it went ahead and sent the data to auth service through WebSocket. Now the thing is, Postgres doesn't handle null characters. So while it was trying to save that data, it crashed. And because of that, our auth service went out of sync with all the other services, and it failed the whole production. So because of that simple null character, which we didn't test against, we had to face a lot of embarrassment at that time. So this is one of the unexpected behavior that might occur in your program. And other than that, there are crashes, hangs, race conditions, which could be there, but you don't know about. And the other things that first testing can identify are logical issues, functional issues. So there are three ways you can like test your, set your first target to find out the functional bugs. First, which we saw, was invariants, the condition which always hold true. So this is the simple reversing example where we double reversed it and check if original is matching the reverse or not. So this was the example for invariants. Other one is round trip fuzzing. So maybe if you are writing an algorithm which takes your input from point A to point B, and if there is also an algorithm which is present which takes B as input and returns it point A. So that you can also use to make sure your function or program is working properly or not. For in case you see, the example is for JSON Marshall. Here we have round trip example because JSON Marshall has counterpart JSON Marshall. So we can test that for round trip fuzzing. And there is differential fuzzing. So you see, if you're trying to write some new algorithm for a particular sorting algorithm, I guess. So at that time, you just don't have to worry about however time it is taking to execute, you just need to worry about the correctness. So there may be other algorithms which are there already for sorting. So you can compare your output with the function which is already written. So you can compare those outputs and you can see if your function is properly working or not. Now that we have seen so many good things about fuzzing, does that mean we should neglect writing unit test cases? Definitely not. Because there are certain limitations to fuzz testing as well. And like some of them are, it is tricky to find functional bugs because you have to check for invariants and other conditions. And the other ones are, it is highly resource consuming process because the process is continuously running. It is consuming a lot of memory, lot of CPU. So at that time, it is also not feasible to run on CI/CD pipelines. And the other one more thing is, you can only run one fuzz test at a time. So this makes it little bit difficult when you're trying to set it for a CI/CD pipeline. Even though it seems little bit hard, but there are possible ways to do it. Maybe you can have a different like G-Cloud service where you are running the fuzz test cases separately. Yes, I see time is up. Just give me 2 minutes. So yes, so you can like write a separate service which is there for just fuzz testing, and you can have unit test on CI/CD pipelines. Or else, what you can do is you can use fuzz testing as a development time activity. Just fuzz test your program whenever you are developing. Now, there are flaws to both unit test and fuzz test, but they are both there to ensure one thing and achieve one unified goal. That is to build reliable, safe, and quality software applications. At last, let's see some tips to write fuzzable code. A code which is hard to unit test is going to be hard to fuzz test. So write more unit testable code, modular code, so that it can help you fuzz test as well. The term is also fuzzy. Pardon me for that. First target should be fast, because while it is running at least 1,000 executions per second per CPU core. So this process is really fast. And your first target is taking more time, then you should like maybe refactor it and try to take it down a notch. First target should be deterministic. That means for a certain input, the output should be same every time. And your first target should not be dependent on global state, because it could lead to some false positives, and it can like insert indeterministic behavior. And at last, if you are still not convinced, or maybe confused about what to fuzz or when to fuzz, how much to fuzz, just fuzz a bit. You will definitely find something. And in most of the cases, fuzz testing can give you all the issues that your code has in like 1 or 2 minutes max. So it is going to be worth it. Thank you all for patiently listening to me, and happy fuzzing.